Okay, we're talking about degrees and radians. So we talked about this last year when we did this as well. So still review. There will be a couple things today that I don't know that we covered last year, or at least not very much. So starting out, we're talking about degrees and radians. Normally we're used to seeing things in degrees, right? All the way around a circle, 360 degrees, right? Right angle trig deals with things that are 90 degrees and so on. Okay. Along with degrees, we have another measure, which is a radian. Okay. It's basically the difference between like Fahrenheit and Celsius, right? So it's just another type of degree measure. And in calculus, we almost exclusively use radians. Okay. In fact, I can't think of a time I didn't use radians in calculus. So first thing for us to talk about is when we rotate around, okay, really the unit circle, right? And we're looking at here, the starting point is called the initial side. As we rotate up, okay, in a positive direction, wherever we're stopping is called the terminal side. And the point where they meet each other is the vertex, okay? So just in a second example over here, right, I would have my initial side. Let's say I rotate somewhere over there. That's my terminal side. This is the terminal. Okay, so here's the initial side. We rotate it around over here to the terminal side, right? Again, that point where they're meeting each other is the vertex. And in this case, we started at the initial, rotated over for the terminal side. Okay, along with that, we need to talk about the different types of rotation as we go around. We'll clear this, that's fine. So let's say we have our XY axis. I'll put a 90. There we go. And we'll do a second one over here. Okay. Any rotation that goes from here up and around, okay, so let's say something maybe like this, right? And then there's the terminal side, right? So we rotated up and around, okay, to the left. This is positive, right? It's positive rotation. We're going to have a positive angle. So let's say I'm just going to make up whatever angle this is. We're past 90. Let's say we went maybe 30 degrees past 90, so that would be a 120 degree rotation, right? So this is a positive angle. All positive angles will start over here and rotate up and around. It could go all the way around and past 360 again, right? That could happen, okay? That's still positive rotation because we're going up and around, right? So it's still a positive rotation. This is just greater than 360 degrees. This might be, for example, let's say it's 400 degrees. It's still positive. It's rotating in a positive direction. Cool. Negative rotation, okay, if positive angles were rotating up, negative angles were rotating down, right? So let's say that we would rotate, somewhere down over here somewhere, right? And we rotated in a that-away direction. There we go, okay? These are negative angles. Okay, so we've got negative angles. We're rotating down and around, right? Up, positive, right? Think about you're going up in the Y values, so that's positive direction. Here you're coming down in the Y values, it's a negative direction. It's kind of how I think of it. And I'm gonna make up some degree measure over there. So let's say that's 180, and let's say we went another, how about 45, so that'd be 225. So we'll say this was negative 225 degrees of rotation. Okay, positive, up and around, negative, down and around. Okay, so the main point of this lesson is degrees and radians. And the thing that we need to understand is their relationship between the degrees and radians and how that works. Again, we talked about this before, but let's say that we have something, right? We have a full circle, which we know is 360 degrees. So that's the degree here. Okay, here's our degree of 360. What if we have the same thing, right? But instead of in degrees, we have it in radians. So let's drag our circle over here, and I'll stay there. All right, there we go. And here is another full circle. Bam. Okay. In degrees, all the way around a perfect circle is 360 degrees. In radians, that same amount, all the way around a circle, is 2 pi radians. Okay, those are equivalent to each other, right? It's, 0 degrees Celsius, 32 degrees Fahrenheit. Same kind of thing, 2 different types of measurement, degree versus radian. So if 360 is 2 pi, then 180 degrees, and let's see if I can line this up. You rotate this in the proper thing, so I just need to go from there to there. That's pretty good. Okay, so 180 degrees would be, well, that's half of the 360. So it would be 1 pi radians. Okay, so here, let's bring this up here. Come on. Oh, I'm not. That's why. Somewhere there-ish. That's pretty good. Okay, and that is 1 pi radians. Okay, so that same thing's going to keep going. We went from 360 to 180. If we go again, that's going to take us into something that's 90 degrees, right? So that would look, like this. Here's our 90 degree rotation. So if we cut 360 into 180, and we cut 180 into 90, right? From 2 pi radians, we got 1 pi radian. We divided it by 2. If we're going 180 to 90, that's another division by 2. We're going to divide that pi by 2. So in radians, In radians, 90 degrees would be pi over 2 radians. And I'm going to put rads because I can't fit it, but you get the point, right? As we keep cutting that in half and in half and in half and in half and in half, okay, our radian is also getting cut in half, right? That's common. And this is the big one, okay? 180 degrees is pi radians. That's what we're going to use to convert any degree to radian or radian to degree, okay, for our conversions and our radian and degree measures. Let's look at an example of that. We have, let's say 120 degrees. And I want to convert 120 degrees to radians. Okay, so the thing I just talked about, right, is that 180 degrees is equivalent to pi radians. Okay, that's the relationship we're going to use here. If we're changing this and we want to go from degrees to radians, okay, we've done conversions in the past in either math or in science. You know that we want to get rid of degrees, so we need to put that 180 degrees in the denominator, and the thing it's equivalent to pi radians goes on the top in the numerator. Okay. What this will do is it will eliminate our degrees, leaving us with radians, allowing us to convert from one to the other. So we multiply across 120 pi over 180. We can simplify this, just lose the zeros, right? 12 and 18 are both divisible by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So 120 degrees is equivalent to 2 pi over 3 radians. No matter what your degree measure is, this pi over 180 allows you to convert it into radians like this. Okay, so that's from degrees to radians. Let's do the opposite. Okay, we're going to take a radian and work it back to a degree. So let's say we have 5 pi over 6 radians. And we want to convert to degrees. Well, if going from degrees to radians was pi over 180, going from radians to degrees will be 180 over pi. Okay, again, the thing that we want to cancel out, the radian is in the denominator. That allows it to cancel, okay? Another thing that's going to cancel is the pi. I'm going to simplify here. 180 divided by 6, that would be 30. And 5 times 30 degrees is 150 degrees. Okay, so 150 degrees is equivalent to 5 pi over 6 radians. This is the way that we can convert back and forth between them. Okay, it's either pi over 180 or 180 over pi, depending on which thing we're doing. Okay, that is our regular conversion. Let's look at, okay, we want to now look at coterminal angles. Coterminal angles. So let's say we have our XY axis again here. Okay, and there we go, bang. And let's say that we have rotated up a positive 45 degrees. Okay. Coterminal angles, okay, show the difference with one rotation around the circle. So we can give two different types of coterminal angle that are still equivalent to this 45 by going all the way around the circle in different directions. Okay, so let's look at the first one. We're going to start from this point and rotate another 360 degrees around the circle. So really we're starting at our point of 45 and we're adding to that 360 times we're going in a positive direction, okay, up and around, so times 1. This will give us one of our coterminal angles. We're going another 360 degrees around the circle. Okay, so 360 times 1 is 360, so 45 and 360. 40 and 360 would be 400. So another 5 makes it 405 degrees. So really what that means, right? Starting from this same point, if we rotate all the way around one full rotation, and then we keep going that same 45, we get back to this same exact point. If we rotate 45 degrees, and if we rotate 405 degrees, that ends up being at the same place. Okay, that's what our coterminal angles are. Let me move this guy up and I'll do the other one here. I don't know how that twice wasn't connected, that's weird. Okay, here we go. So a positive direction, we're going up and around this way. A negative direction, right? It's almost exactly the same thing, but instead we're going the negative 360. So we're gonna do 45 plus 360 times -1, okay? All that ends up doing is instead of adding 360, we're subtracting 360. So if we're going from this point around 360 degrees in a that way direction, right? We end up back at the same place, okay? So what is that measurement? -360, if we're adding a 40 to that, that would be -320. We lose another 5, so -315 degrees. Okay, and what that means is, again, if we start at that same beginning point here, and we rotate around in a negative direction, 315 degrees, we end up back at that same 45 measure, okay? That's the concept of a coterminal angle. We have multiple different ways that we can get to that same point, right? And from any angle, if we add 360 to it and we subtract 360 from it, then we're going to be able to find the coterminal angle, okay? It's a 360 degree difference in both directions, right? So one of them you add 360, the other one you subtract 360. Okay, arc length. For arc length, we are going to have some kind of arc. So if we look at this circle, right, we're going to have some slice of this pie that goes, maybe to something like this, right? So we want to find the length of that arc from that point to that point, okay? Here's what we need for that. In order to find the arc length, you will take the radius and multiply that by the degree in radians. That's a specific thing. So in this, your degree must be a radian. Okay, for arc length, we gotta have a radian. So here's an example, right? Let's say that our radius is 5, and let's say that our radian, our degree measure, is pi over 4. Okay, the arc length of some slice of pie here, right, that has a radius 5 and an internal measure of pi over 4 we're going to multiply that together to find this arc length on the outside. So 5 times pi over 4. We just multiply it in. That would be 5 pi over 4. And that's the length of the arc from one point to another, right? From here down to here, okay? Arc length is that simple. What's the radius? Multiply it by the radian, okay? If, for some reason, instead of radians, what if you're given degrees, right? So let's say here's our slice of pi, right? We'll make it about the same size. Let's say that the radius this time is 2 and the degree is 60 degrees. Well, step 1 is going to be to change this to be a radian. So 60 degrees times, we want to cancel degrees, so pi over 180 degrees. That's 60 pi over 180. And we would be able to simplify that. That is going to simplify down for us to be pi over 3, right? They're both divisible by 60, so pi over 3. That's our new radian. That's what this is equivalent to, right? So we can say that that is the same. All we have to do now to find that arc length is take 2 times pi over 3. So the length of the arc from here to there is 2 pi over 3. That's the arc length, right? The radius times the internal measure in radians. You have to have it in radians, not degrees. Okay. All right, let's look at area of a sector. So area of a sector, very similar to the thing we just talked about. If we look again at some slice of the pie from here to there, right? A second ago, we found this outside edge. Right? We found the length of that thing, arc length. Now we want the area of this sector. So what that means is we want everything in here. We want this whole slice of the pie, how much space that thing takes up. Okay. Our formula for that is going to be 1/2 times the radius squared times the degree. So the area of a sector is equal to 1/2 the radius squared times the degree. And again, just like before, our degree is in radians. Okay, so if you're given degrees, you have to change it to a radian first. All right, so here comes an example. Let's look and say that we don't need all that stuff. All right. The sector's central angle is 7 pi over 8. And it has a radius of 3. Okay, so our measure is given in radians, 7 pi over 8, and the radius is 3. So our area, I'm just going to say A, is equal to 1/2 3 squared, put that in parentheses, times 7 pi over 8. So 1/2 times 9, or 9/2, times 7 pi over 8. 9 times 7, that would be 63 pi over 16. And that is the area of the sector, right? It's not going to simplify. So we are able to say that the area of this sector, the slice of pie, takes up an amount of space that's that big. And we could take a calculator and we could type that in and figure out what it is. I'll do that just so you can see what that would look like. 63 pi divided by 16. And that's approximately, and we weren't told here inches or centimeters or whatever, right? But that's approximately 12.37, right? So that would be 12.37 inches squared or feet squared or what have you, right? But either way, this is the way that we find the area of the sector. It's 1/2 times the radius squared times the degree measure in radians. It's got to be radians or it does not work. Okay, there might be one or two other little things, but I'll talk about them in class. Okay, I don't have enough time to go over it now, and I think it'll be easier anyway. Okay, thanks.